Today, we're going to talk about one of the most mysterious problems in mathematics. But before we begin, I want to thank all the teachers who guide us through the world of numbers and letters. They show us not only mathematics, but also the beauty of learning anything. They teach us problem solving, perseverance, curiosity, not just information. So, happy Teachers' Day to all the teachers who've been with us on this journey. Now, let's play a very simple math game. But let me warn you, nobody in the world has solved the secret behind this game. The smartest mathematicians have tried. They gathered, brainstormed, attacked the problem, and still couldn't solve it. It's gotten to a point where they even advise people not to waste their time trying. What's this game, you might ask? The rules are simple. Pick a number. Any number you like. I'll pick one too. I'll even show it to you. 6. I'm going to throw this number into a box. This box can only do two things with the number. If the number is even, it divides it by 2. If the number is odd, it multiplies it by 3 and adds 1. Every time it gives me a new number, I throw that number back into the box, and the box continues. Ready? I throw in 6. It's even. The box divides by 2, 3. 3 is odd. Multiply by 3 and add 1. 10. 10 is even. Divide by 2, 5. 5 is odd. 3 times 5 plus 1, 16. Then 8, 4, 2, 1, 4, 2, 1. We're stuck in a loop. We entered a cycle. No matter what number you choose, you eventually fall into this 4, 2, 1 cycle. This strange process is called the Collatz Conjecture, or more casually, the 3x plus 1 problem. It claims that every number will eventually reach 1, but nobody has been able to prove this mathematically. Is there a number somewhere that escapes this pattern and grows forever? Is there another loop hidden somewhere in the infinite universe of numbers? We don't know. This problem has remained unsolved for almost 90 years. Before we go deeper, it's worth pausing to realize how strange this really is. A rule so simple that anyone can understand it. Divide by 2 if it's even, triple and add 1 if it's odd. And yet, behind that simplicity lies a mystery that has defied the greatest mathematical minds for decades. Think about it. The entire structure of this problem fits into a single line of arithmetic, but its behavior mirrors the unpredictability of the universe itself. It feels almost alive, rising, falling, looping, refusing to reveal its pattern. This is what makes mathematics so fascinating. It's not just about numbers. It's about searching for order in what seems like chaos. Every time we look closer, we find beauty hidden in logic, and logic hidden in beauty. Maybe that's what keeps us curious, knowing that even something as simple as 3x plus 1 can remind us how much we still don't understand about the world. If you want to improve your English, now is the moment. Shall we continue with 3x plus 1? Many of the world's most brilliant mathematicians have worked on this, but neither a proof nor a disproof has been found. Erdős, one of the greatest mathematicians in history, said, "Mathematics may not be ready for such a problem." And unlike the Millennium Problems, there is no $1,000,000 prize for solving it. Why? Because the Collatz Conjecture doesn't seem to produce new mathematical tools or discoveries as we work on it. You could spend years, decades chasing it, and end up learning nothing new along the way. That's why they advise young mathematicians not to spend their careers on it. The first obvious approach is brute force. Test every number one by one. Mathematicians have tested every number up to 295 quintillion using computers, and every single one eventually reached 1. But what if there exists a number bigger than that? Testing forever is impossible. We need smarter ideas. Another approach? Count how many steps a number needs to reach 1. Some numbers reach quickly, like 5. Others behave wildly. Take 27. At one point, it climbs to 9,232 before falling back down, eventually reaching 1 after 111 steps. If you graph this behavior for huge numbers, it looks random. until you take the logarithm. Then, something amazing appears. The graph looks like geometric Brownian motion, like a random walk of a rigged coin. Looking at the problem as a tree rather than isolated calculations helps too. If the conjecture is true, every number eventually connects to the tree. There can be no endless branch or isolated loop. Reverse the process and things get even more interesting. With negative numbers or different formulas like 3x minus 1, multiple loops appear, not just one. Mathematicians even tried generalizing to 3x plus n, ax plus n, and other variations. Chaos everywhere. Yet 3x plus 1 remains uniquely mysterious. Another strategy is to look at the maximum value a number reaches before collapsing. If you plot these values, strange patterns emerge. Everything seems to stay under a certain boundary. In 2019, Terry Tao pushed this idea further and established a limit. He described his discovery like this. This is as close as we can currently get to solving the Collatz conjecture. A problem that looks simple, but may require mathematics we haven't invented yet. Erdős was probably right. Maybe we simply don't have the tools. And that's why the Collatz conjecture sits on the sidelines. Unlike other problems, the journey toward its solution doesn't gift us new mathematics. Or at least, not yet. Maybe the value isn't in the struggle to reach the solution, but in what we learn after we finally solve it.
We've reached the end of another video, friends. If you like this video, don't forget to like it. We'll learn a lot from the videos I share. Don't forget to subscribe to my channel so you don't miss my new videos. See you in the next video.